Tēnā koutou katoa, and good afternoon, and a very warm welcome here to Lincoln University for our brand new Bioeconomy Series. My name is Grant Edwards. I'm the Vice Chancellor here at Aotearoa, Lincoln University, and it's a real pleasure to welcome you here for this series of events about, as part of our Return to Campus Week. We not often have many students sitting out on the green out there, but we're also trying to create a bit of focus around the science, the innovation, the policy work that we do here at the university in conjunction with our partners. We're really pleased today to launch this series, which is the Bioeconomy Series, a new initiative delivered in partnership with the Bioeconomy Science Institute. The partnership is about much more than simply running events together. It's about bringing our strengths, perspectives, and networks into closer alignment so that our research can better support farmers, industry, policymakers, and communities to navigate real-world and pressing challenges. It's about creating some spaces to have dialogue, test ideas, and viewpoints in what we do. I think it's important that we reflect on that this is a partnership, and I've had reasonably long conversations with Mark Piper, Chief Executive Officer of the Bioeconomy Science Institute, who isn't able to be here today, but would like to share some thoughts over video about this particular program.
Kia ora everyone, I'm Mark Piper. I'm the Chief Executive at the Bioeconomy Science Institute, and while I can't be there in person today, really happy to be alongside Grant helping kick this off what will be an amazing series. So Bioeconomy Science Institute, Maiangi Taiao, is probably the largest research organisation in New Zealand that you've possibly never heard of. So we were formed about 8 months ago, bringing together 4 Crown research institutes into an amazing institute that is focused on sustainability, our environment, our economy, the things that grow on the land and in the sea, and how we protect our whenua and our awa as part of this. So really fortunate I'm coming to you today actually from our Tuiraki building, our head office here on the Lincoln campus. And real privilege for us to be launching this Bioeconomy Series in partnership with Lincoln University, a fantastic university in New Zealand, so we're very privileged to be part of both the campus and this series. This first one today, focusing on something that's actually really front of mind for rural New Zealand. What are our land use options for the future? What are the things we can be doing that both drive prosperity in our regions, economic growth for our country, but also the right things for our country, for our land, for our iwi partners, for ourselves, the people that inhabit this sort of area. So enjoy the session, and we hope to see you along for all the ones as we go forward for the year ahead. Ka kite.
Okay, and thank you, Mark. To kick us off, we have 2 widely respected and highly respected researchers who bring complementary perspectives to this conversation about land use in a changing climate. First of all, we have Professor Anita Wreford from Lincoln University. Professor Wreford is an applied economist specialising in climate change adaptation, particularly in agriculture and the primary sector. Joining here today is Dr. Alec Mackay from the Bioeconomy Science Institute. Dr. Mackay is principal scientist based at the Browsons campus in Palmerston North and a leading figure in soil science and pastoral systems. His research focuses on the long-term impacts of agricultural practices and climate on soil health, nutrient cycling, and ecosystem services in particular. Together, our speakers bring deep expertise across economics, climate science, soil science systems, and land management, and exemplify the kind of collaboration and applied research we hope to showcase in this series. They'll be involved in presentation, and then there will be essentially, once that is completed, Lincoln University Professor Chad Hewitt will chair a moderated discussion about where there will be an opportunity to ask questions, followed by a light afternoon tea. Thank you for your time today. And I think first of all, we welcome Anita and Alec. Thank you.
Thank you, Grant. Kia ora koutou. Thank you very much. Thank you, everyone, for coming to this session. It's quite exciting, a little bit daunting to be the first in this series. But when I heard that we were going to be having these collaborative series between Lincoln University and the Bioeconomy Science Institute, I thought this would be a great opportunity to share with you some work that Alec and I and colleagues have been doing over the past couple of years, looking at land use and a changing climate. So I'm going to start off and introduce this project that we have and talk a bit about the background, the rationale, and so the first part of it, I'll hand over to Alec, who will present the work that the bioeconomy team have been doing. So this is funded by MPI, and it's actually funded by the inventory team, which is a little bit of an unusual sort of project for them to fund because usually it's more about really directly understanding emissions. But clearly land use has a big impact on our primary sector emissions. So that's where that comes from. As Grant said, it's a very diverse, or quite a diverse in terms of discipline team. We've got from Lincoln University agricultural economists and some climate change expertise, adaptation, and then at the Bioeconomy Science Institute we have really a lot of soil, plant, pasture, livestock, farm systems expertise. So between the two of us, we sort of cover some areas that are relevant to the topic. And I guess, well, I'll start by telling you the rationale for it. It was kind of in the aftermath of Cyclone Gabriel when the call came out for these potential projects looking at land use. And I was talking to Robin Dines and we were just discussing, you know, some of these images that were across the media then and have been again since. And thinking about how can we make better decisions about our land use now so that in the future we're not dealing with these kinds of problems. How can we improve our decision making? And surely between us and our different areas of expertise we can contribute something to this question. So really that's the kind of underpinning aspiration for the project. And I say aspiration because it's, although we've got a big team, a relatively big team of really experienced researchers, it's not a massively funded project. So it's quite a small project actually. So we've really been able to, I guess, scratch the surface of some of the questions that we have wanted to look at and look at, identify areas that it's probably worth spending a bit more time and resource into investigating further. And I guess our other rationale was also trying to get a bit of an understanding about what these decisions, what the impact has been on our economy, society and the environment. And we've gone some way towards achieving those goals, but there's still a lot of room for more work. And as I said, it started in 2024 and we're just coming to the end of it now. So we're working on our final kind of reports and well, this is one of our dissemination activities. So I guess when we thought about land use and decisions, what shapes land use, we thought we should really look back and understand what has shaped our land use in Aotearoa, New Zealand in the past. And so of course it's a whole range of factors. So some of these are driven by, well, of course we first had colonisation or human civilization arriving here and then colonisation, which was a massive change in the land use. And then we had policies that actively drove clearing the trees to make way for pasture. Then we had kind of technological advances like top dressing, which allowed us to fertilise areas that would never have been able to be to grow pasture without that. And then we had things like refrigerated shipping, which allowed us to export our sheep meat. This is a picture of the very first refrigerated ship to the UK from Dunedin, which allowed us to then expand into markets overseas. And, you know, the UK was traditionally a big market for our sheep meat and dairy products. So all of these things have kind of driven the land use that we have now and our response to events. So this is an image from Cyclone Bola, which destroyed that kind of landscape. And the response at the time was a political one to invest in plantation forestry on that steep hill on those steep hillsides, which did stabilise the land for a while, but then of course no thought about what happens when we need to harvest them. So these things are all kind of interacting and have led us to where we are now. And now we've got a changing climate. And that kind of sits across all of these. It affects our land use directly and what we can grow in different parts of the country, but it also affects most of these other factors as well. And so we realised quickly that this project wasn't going to be about modelling climate impacts on agricultural production, because that isn't really going to tell us about how the land is used into the future. And when we talk about climate change, of course, as well, it's not just one kind of future climate. You'll be aware that there are a range of projections which depend on our socio-economic conditions. So we've got modelling that looks at the climate forcing under a range of different scenarios, and these scenarios are driven by global changes in population and trade agreements and economic development and things like that. So there's a whole range of futures that we should be considering when we're talking about climate change. And there's a lot of work that's gone on in understanding what that means on agricultural production in Aotearoa, New Zealand. So we have a really good, well, quite a good understanding of the impacts of climate change on different agricultural and horticultural systems. So there was a lot of work that went on in the National Science Challenges, particularly our Land and Water and Deep South, which looked at land use suitability, impacts on different systems. And if you're interested in that, it's still all collected and collated in this data supermarket, which is available at that website. I'm not sure if you can see, but it collates all this work. And so we didn't want to replicate that because that's already gone on. And as I said, we didn't have a lot of resources. And then when we think about the future and what that might mean in terms of these other drivers of land use that I was talking about, so not just the climate impacts, but the socioeconomic changes, the political changes, there's been a bit of work, not a huge amount, but exploring what they might look like for land use. And the Aotearoa Circle has done quite a nice job of, I guess, taking those global scenarios and bringing them down to the New Zealand level, not so much a regional level, which is where we tried to add value, but developing these narratives about three alternative futures, looking at different kind of global, political and local contexts. And that's the first part, I guess, of our project, was trying to flesh these out a bit more for what they really mean for the primary sector in Aotearoa, New Zealand. And I'm just going to take a few of them because there's a lot of the narrative scenarios. So there's a lot of kind of discussion and lots of different aspects within them. And so I'm just going to pull out a few that I thought might be useful. And I know Alec will draw on these when he talks about the work that they've done as well. So the first scenario that we've looked at is called an orderly scenario. So this is sort of, in a way, the best case that you can hope for. It's basically we have gradual and managed policies both for reducing emissions and planning adaptation. They're implemented now and they just continue gradually until we've achieved net zero by 2050. And the primary sector in this scenario is really supported. So if there are farmers who are struggling, we help to exit the industry. There's a lot of investment in ensuring equitable access to technology and resources and things like that. In the disorderly scenario, we kind of ignore what's going on until 2030 and then realise, oh my, this is not good. And then stringent policies for emissions reduction are put in place. So things like planting lots of areas of trees and cutting out livestock emissions and things like that, but very quickly after 2030. And adaptation isn't addressed very strategically, so it's uneven and reactive. After extreme events happen, we sort of just build back, wait for the next event, and no kind of long-term planning. And the hothouse scenario, we kind of have no policies and anything. It's a free-for-all, really. And of course, the climate impacts the global temperature increases in this scenario are the highest. They're assuming an increase of 3 degrees warming by the end of the century, and it's just a very disruptive and a kind of future that we don't really want to be in. So we tried to think about what they might mean for land use and production. And so in the orderly scenario, there's quite a lot of demand for low emissions products globally, as well as in New Zealand, high value products, medicinal products. There is an increase in forested area, but it's including native forested area. There is a general decline in primary production because we are still getting the impacts of climate change. They're not quite as extreme. In the disorderly scenario, there's limited diversification because the impacts are becoming more intense compared to the orderly scenario. Some regions are becoming unsuitable for production. Farms are consolidating because the smaller farms are not getting the support that they need. So the bigger farms are investing in, they're able to invest in technology and adaptation, and they're buying out the smaller ones. And the native forest area increases, but it is under pressure from pests and diseases and fire. And in the hothouse scenario, the sector contracts because of the challenges to production from the climate impacts. In some areas, production basically leaves completely and moves to where it's less affected by climate change. Native vegetation does expand, but it's not very healthy. It's not managed. Pests and diseases and fire prone. There are some innovations. So because of necessity, there's vertical and indoor farming. There's some urban gardens. In the Māori agribusiness areas, some of these systems persist based on traditional knowledge, but in this scenario, there's also quite a Māori Pākehā divide actually in society. So that's challenging as well. Water availability is kind of interesting because across these scenarios, it's assumed to become more important, but in the orderly scenario, there's been investment in storage that's able to be accessed by different groups across society, not only agriculture and not only large farmers, but everybody. Whereas in the disorderly scenario, there is only the larger farms are able to afford irrigation and things like that. So it's kind of interesting to look at how our policy responses and planning can moderate the actual physical impacts across these scenarios. And just finally on this, the trade and our markets is quite different across them as well. So in the orderly scenario, everyone's kind of concerned about low emissions products. So there's an increase in demand for those sort of low emissions, either alternative proteins or really high quality livestock products. In the disorderly scenario, there is demand for premium and sustainable products, not commodity products. But there are also increasing global trade barriers. So I think this is important to remember that we might be able to grow things in certain regions, and there might even be opportunities to increase our production in certain regions. But if there's no market for them, or if our global trading system has shut down, or shipping costs are really high in some of these scenarios, and we're not able to export them, then that's a challenge. And in the hothouse scenario as well, there's a tension between actually having enough food to feed ourselves and exporting it for export revenue. So I think these scenarios, the idea is to really just, none of these are going to be right, and they're going to have aspects of, each other and across them, but they do allow us to think through what alternative futures might look like, and then make conscious decisions about how we can either avoid one kind of future or hopefully go for a different one, and think about what we need to be doing now so that when these climate impacts and other events occur, that we're prepared and we've got the technology, we've got the systems and the structures to enable us to adapt. And so globally we might be in a high emissions hothouse world, but we could still have orderly policies here that would actually manage those and the way we experience them quite differently. So then this is kind of interesting, and I enjoy thinking about these kind of things, but then we came to the crunchy part of the work where we tried to convert these narratives into numbers, because another part of the project was trying to understand, you might recall, the economic implications of these different land uses and changes. And that was quite challenging, and I really thank the team who did that, who took these kind of stories and thought about, well, what does this mean for the numbers of dairy cows? What does it mean for employment, etc., and put them into a couple of models that we have. I won't spend too much time on these. One is a linear programming model, and the outputs from that went into the integrated assessment framework, which was developed by the AERU. Have to have our former director here, so I have to slip that in. And that kind of allowed us to look at quite a few different variables, and I'm just going to share a couple of them here in the interest of time. So as you recall, this is funded by the inventory team. So we looked at greenhouse gas emissions. I'm sorry, the colours don't really allow a great comparison, but if there's four blocks of bars, and the one on the left is our emissions from agriculture in 2022, so it's kind of a comparison, and then we've got the orderly, disorderly and hothouse scenario on the right of that. So you can see, and the yellow bar is our gross emissions, the light blue bar in the middle is the carbon that is sequestered by and stored in forestry, and the dark blue is the net emissions. So you can see that there are reductions in our gross emissions for all the scenarios. And I think in the orderly one, it's as a result of policy mostly. And the disorderly and the hothouse one, it's a little bit of a mix of changing production away from livestock as a result of consumer demand, but also the impacts of climate change. Like, it's just becoming harder to produce these kind of products, so there's a decline. Forestry varies a bit across the scenarios. And so, yeah, it's just a starting point, I guess, for discussion about what this means for our emissions and how we want to go into the future in terms of policies or reacting to events. And then we looked at our gross output across these scenarios again. And this is from the integrated assessment framework, and it looks at what this might mean for the regions. And I think this is an interesting comparison because you can see that the regions actually are affected really differently. So in the orderly scenario on the left, there are some increases in gross output, particularly in the southern regions, you'll notice. And this is likely because they're actually less affected by the climate impacts as much as the ones in the north. But in the disorderly and the hothouse scenarios, almost all regions experience a decline in the gross output. And yeah, I mean, some are quite significant. And I think we'd want to tease out a little bit more what this means, and try and put some of those numbers on a wider range of the variables from the narratives. Like, this was a first attempt at trying to convert those narratives into a quantified impact. And I think it would also be interesting to look at if we could kind of look at some of the costs of investing in, like, water storage or those kind of transition costs, and comparing them with the different futures as well. So there's plenty of more work that we can do in this space, but it's kind of, yeah, outlining, I suppose, how the regions will look different. And I think when we talk about regions, it's a good time to hand over to Alec, because I've sort of presented the high level national, regional consequences in a way and processes. But when we got to this point, we realised that actually, to really understand the impacts on the ground, we need to get into more detail at a much more granular scale. So, Alec, I might just pass over to you if that's all.
And good afternoon to you all. And again, just following on and taking that sort of narrative that Anita described, sort of a national perspective. And so this part of it was just to take that narrative down to one region. And then the other part is to then see through also the modelling work what the narrative looked like in terms of the land use change that might occur, and then attempt to actually put that on the ground and see what it actually looked like on the ground for a budget, which was about that way. So there's a lot of assumptions, and we moved over the ground really quickly. But we actually picked the SK, Traffic Gisborne, as our sort of area to focus in on. And it's unique, it's unitary authority, along with Nelson, Marlborough, whereas the rest of the country, regional council, so it has both a regional and a local role. It's a small population, 1% of the population, half of it's actually married. It's got the highest proportion of people under 25 in the country, which is an interesting fact, and income below the national median. It's a relatively small part of the country, 3%, but if you haven't been there, it's got some of the most amazing, magical coastline and beaches in New Zealand. It's a sort of a hidden gem. It covers 25% of the land is actually owned by Maori, and the key industries are around the primary industries. And it has 25% of the severest eroding land in the North Island, and nearly 90% of the land is in AUC class of 6 to 8. So apart from a small coastal area in the inner area in and around Gisborne, it's essentially all country and steep land. And I think importantly, it's also been the target of central government initiatives going a long way back. My memory goes back to Bowler and East Coast Forest Accord. There's been a lot of policy that have come out of central government following these extreme events that have had a large footprint on what we see on the ground today. Some good, some bad, and hopefully future policy might improve the good and reduce more of the less effective. One of the other interesting things that I call it the climate change office, but certainly the inventory team was interested in is what happens to actually land use, because one of the things they report on is this land use change in forestry categories. And that's those categories.
Speak up, please. Can
Sorry?
you speak up, please? We're having trouble hearing you.
Okay, thank you. The land use change and forestry categories are defined by the. Okay, so going back, the LUCF categories are defined by IPCC, and it's used by MFE to report on the greenhouse gas emissions removed from New Zealand. So what's happening to our carbon budgets? So if we look at the Gisborne district, over half of its forest land, and that forest land includes both native, regenerating native, exotics, and all those pieces of landscape with trims on that would fit the criteria of eligibility for the ETS. Areas that are larger than a hectare, greater than 30 metres wide, trees that achieve a height of more than 5 metres with 30% ground cover at maturity. And obviously grasslands is the second major land use. I want to just go back through and we deepen the narratives around each of those, the baseline, the orderly, disorderly, and then the hot hours. But just a bit of a baseline to reflect on where the region is from our perspective. And so it's not a complete. I've cherry-picked some of the information out of the latest report, but it reflects sort of current land use patterns, the fact ongoing exposure to weather. We've just seen a couple of events even in the last month. Ageing infrastructure, decline in farm productivity in those vulnerable areas. Sheep beef sector has gone through a period of low returns up until 18 months ago, and it's seen low adoption as a consequence of the lack of capital. So you head around the exotic forest, stable or declining areas just in recent years, both at sort of that small scale. Ongoing, obviously, storm impacts, and obviously they're in the news around slash and its management. And obviously the roading infrastructure is a real question about we can get goods and services in and out of some of those areas. Natives, we're seeing some regeneration as a consequence of that de-investment in the pastoral sector, but there's an enormous increase in pressure on feral animals, deer, pigs, goats. It's a national issue, but the numbers in there have never been high, and it's just been identified in some other parts of the country, but it is a national issue, the build of feral animals. But the grassland area, livestock numbers have been sort of sustained. Cropping is a very small part, really constrained to Gisborne Plains and some small areas up the coast of Rotorua. And like most of the country, only 1 or 2% of wetlands are reserved. That's a sort of a national issue. We've lost more than 90% of wetlands across the country. Look at the orderly. And this represents if we get our act together, we take a coordinated approach, protect those fragile landscape units through expansion of both the native regeneration and afforestation. That might include native and exotic. We get on top of the feral pest, and we make some improvements to the existing livestock systems. So under that right tree, right place, using both natives and exotics, we can see a significant expansion over the next to 2050. And that would be driven through the Rafferty resource management plan that has just been renewed right now. So we could see up to a 20% increase in the areas in exotics and natives over that period of time. And if you put that alongside the control of feral animals, a significant change to the landscape into the future. You'll see an equivalent contraction of the pastoral sector, little change in livestock numbers, but potentially the adoption of new technologies for management of livestock. The collars with the potential to manage the location and movement of animals could be a game changer for beef cattle in hill country in New Zealand. They offer a way of managing those animals without the need for expensive infrastructure, being able to control animals into areas quite strategically in the landscape. They could be a game changer for the sector in the future. It's a different infrastructure need from the ones we've got running currently now. Some slight change in the cropping and an increase in wetlands. It still seems a 5-fold increase is still a small amount, but it is a progress in the right direction. If we look at the disorderly, as Anita said, there's a delay. We delayed from 2030. And then all of a sudden we go into one of these, we have to do something. So all of a sudden we're going to do everything tomorrow. So we get an abrupt deforestation, causes disruption. It leads to uneven adoption and so less effective. So you will see some increase in deforestation, potentially up to 10% on the freehold grasslands. But Maori landowners might take a different approach, right tree, right place. So you could see a different approach being taken as they're more organised. But continue to struggle with that feral animals unless you've got a program that's organised and routine. Then you only have to miss a year here and there, and you're back where you started. So that disorder does create uncertainty. The grasslands are decline, and you'll see limited adoption of new technologies because of that uncertainty around investment. And again, the wetlands are further delay before we look at restoration in that particular area. We go to the hot housing, and then we just assume it's free market. We'll just, what will be. Intensive, as you said, impacts of climate, ongoing degradation of the fragile land, increased erosion, continued loss of biodiversity. And we could actually see a loss of exotic forest over that period. Wilding plants become an issue. So an actual decline in exotic, but a large increase in Manuka-Kanuka regeneration in native forest. Again, that's part of that de-investment in the pastoral sector declines. But we could see a continued decline in the health of native forest if there's no management of feral animals. Farmers are up there putting deer fencing to keep feral animals from getting into their farms as opposed to keeping deer in their farms. So you're seeing people deer fencing to keep goats, deer actually out of their farms, which is an interesting shift in behaviours. And obviously a reduction in the pastoral sector, you might see some intensification in some areas, but just an ongoing decline. Maybe expansion of cropping onto some of those eroded landscapes, just driven by year to year, and the loss of wetlands continue. Just to finish off, one of the things we tried to do was taking just the orderly, which represents sort of that early coordinated intervention. And if you look by 2050, that 10 to 20% translates to another 50 to 100,000 hectares of the region going into some sort of forest cover, and the grasslands contracting by the same amount. So using the narratives we develop, the model outputs for each of the scenarios, along with literature and some local knowledge, where are those changes likely to occur within the region. So without going into real detail, if you take the map that's got the red and blue on it, we took out the layer out of the resource management plan for Gisborne District Council, the Land Overlay 3A, which is identifying, that's the areas in blue, identified as eroding slopes. an initiative that goes back to about 2007, 2008. And more recently, they're developing a land overlay 3B layer, which is around landsliding and gulling, but also its connectivity to water. So we've actually got a matrix of both increasing risk of landsliding increase and access to water. If we take those areas and overlay them or intersect them with the current land cover, then we produce a map that the green areas on that map are areas existing over land overlay 3A and 3B, which have got forest cover, and the areas in yellow are those that are still in pasture. And so it's starting to provide a bit of a picture. If we were to take those areas in yellow out of whether it's with forests, with allowing regeneration or with conservation plannings, a picture where under an orderly scenario land use change is likely to occur. And you can see it's at that sort of southern end of the region, as opposed to the northern, and maybe some of that coastal belt just north of Gisborne, up around as you get up towards sort of Tukumara and Whalaga Bays. It's interesting, generated sort of similar numbers doing this exercise from the modelling, which gives a little bit of confidence, although we know most models are wrong. But they are still based around using OUC land capabilities, so there is some underlying reason why they should have. Hopefully there is some synergy. But if you put the pedestrian layer over there, putting aside the limitations of the scales of some of these data sets, you can start looking at what this means at actually property level. And clearly farm scale is a scale at which decisions are made. And you can start looking at, what's the extent of change and implications for decision making into the future on these properties. And some sort of idea of insights and levels of support required to affect any change. For adoption, what sort of level of support will you require to actually affect change? Because for some it'll be little, but for others, it represents a significant change to their farming business. I suppose this map also provides a spatial layer to examine, for example, change in emissions. Also back to the Climate Office, it gives you some idea of maybe rates of change that you're moving from grasslands to a forest cover. It gives them great certainty in terms of their reporting into the future. And I suppose it's also a feeds back into a little bit learning about the modelling exercise, how can we make that a little bit more sophisticated. And I suppose it's given us enough enthusiasm, if we had a bit of resource, to look at some other regions that have got a different mix of land uses and challenges to see whether we can deliver the same. So, well, thank you. And I think oh, sorry, my apology, there was a slide. Oh.
I don't know. I think I've got a. Thanks, Alec. I just had, we as a project group developed some kind of its main points coming out of this work is a kind of thinking about where we could go next or the important findings that it's revealed to us. So one of these things is the scenarios are interesting, and a lot of the modelling that we do provides us with sort of proportions of land use and different land uses, but where they are in the landscape really matters, and our landscape's very different around the country, and so having this more kind of granular level of detail allows us to really understand and think about what kind of policies and actions we would like so that we get to a future that we would like. A question that kept coming up is actually, do we have the data that we need to understand and do this work in more depth? And it reminded me a little bit when Simon Upton came and talked. He was talking about data available. Partly we do have the data, but it's just not available in an accessible space for people to use and make decisions. But in other cases, we don't necessarily have it. And then for me, one of the interesting points, and I just think is so important to think about in these times globally and nationally, but really this leadership and policy and strategy are just so critical to how we experience the kind of, in many ways, inevitable changes that will come. Like, we have a limited opportunity to influence the levels of warming that the planet will experience, but we can really affect how we experience them in New Zealand on the ground. And then we were thinking about this series as well in our collaboration between the university and BSI, and between us we've got really a lot of, I don't mean this project team, but between our institutions we've got a lot of expertise and experience to really actually provide some leadership in this space. So I think it's an opportunity when we work together with our colleagues across there to think about how we can make the most of that. And I think now would be really great if we can hear, your thoughts and have a conversation, a discussion about what you've heard. A lot of what this project was actually having some really interesting discussions because it's just, there's so much potentially going on. So thank you. And there are other members of the project team around, so I'm going to ask them to come up as well to share the share with us.
Well, thank you for participating in the event. I think we're going to need to go through and introduce everyone. And I'm going to ask you guys to use your big boy voices. Right? We know Anita has a decent voice. Okay. So John, do you want to start?
Yeah, how's it going, everyone? I'm John Saunders. This is my big boy voice. Very rarely shared, so feel very honoured. I'm an agricultural economist who specialises in trade and the environment, and I'm just here from across in the building at our commerce facility there. So wonderful to be here. Thank you.
Thanks, John. Mike Line, sort of recently retired from Lincoln, but still working here. An ag economist by training, with discipline for mathematical programming and modeling.
Okay. So I'm Rennie, another agricultural economist, and I'm an interdisciplinary team, professor of agricultural economics. It's still working at Lincoln University and really looking quite a lot at future use of land.
Yeah. So we have a number of moderated questions that the panel's been exposed to. I'll go through those, and then we'll open it up for a wider discussion. And you don't all have to answer the questions, but perhaps if you have something novel to add, it would be really useful. The first question, from your different research perspectives, what do you see as the biggest climate-related challenge for future land use in Aotearoa? John, do you want to start?
Yeah, so my perspective is usually outside market. So the tempting thing would be to say, as climate change comes in, people around the world want different things. But really, New Zealand's in a space where we're usually doing high value goods. And I think we can continue to do so depending on the expansion of China, and incomes in China will be kind of one of the biggest drivers of that over the next sort of 70 years. So I'd say kind of conversely, the thing that will happen for us with climate change and our biggest challenge is just regulation. That's probably the thing that's going to have the biggest impact, is how we as a country respond to these challenges. And it'll be that policy which will be the biggest effect on our agriculture. So I think there'll be some much better answers about our own adaptation to the physical side of it. But in terms of the impact, us deciding what the regulatory space is and how we're going to have a productive and successful agriculture while maintaining our climate goals is going to be the thing that I think will have the biggest impact going forward.
Thanks, Mike.
Yeah, I very much agree with that. I know the environmental problems that we see quite regularly now are very foremost in mind, but I would agree that it's the changes in the markets, the global markets, that are really going to impact our land use. And our policy is probably going to be very reactive in trying to address the issues as they arise. So that's less than orderly approach is probably going to be the one that we follow. Thank you.
Nita?
Yeah, I think the biggest risk is that we're not going to take it seriously enough, and we're being overly confident that we can adapt to the impacts without having a strategy and plans in place.
And I think I agree. Agricultural economists think the same. I think I agree with a lot of saying that. But yeah, I think we've got that mixture of the mitigation versus the adaptation as well. So the mitigating will be, in a sense, the response to those regulations and the policies that are going on. But at the same time, that's got to take into account how we're interacting as we adapt to the climate change. And I think those two things are going to be important in our land use.
Thanks. Alec?
Yeah, so
two thoughts, I think, in addition to the increased sort of volatility. So I'd probably take a more biophysical perspective as opposed to sort of the other end of the market. But increasing sort of volatility as we gain up some more moisture on it, then increasing disruptions. The other thing we've come across in more recent years is that under our change, we seem to be growing less. Our pastures seem to be growing slower, and our forests are growing slower. And if we go back, that's probably been happening for. Sorry, I'm not. My apology. I never been talk about being too quiet. Sorry. And I think in addition to that increased volatility, what we've been finding, and it's really been taking our attention for the last 3, 4, 5 years, is that things are growing slower. Our pastures are growing slower. We're growing less pasture now than we were 20 years ago. Our pine trees are growing slower. When there was some expectation of the changing climate with warming and increased CO2, the expectation the parts of the country were going to grow a bit more. And so the data was accumulating up and down the country to show that we're actually growing less. And in fact, if you look at the SFFF that's just been launched, the Upper Waikato in the Northland, Dairy NZ, Beef and Lamb, AgResearch, and a few other players, they've calculated cows in Northland are eating a ton of less pasture dry matter per decade going back to 2000. An analysis we did at Dairy Base, which is up and down throughout New Zealand, if you compare milk production, and these are back calculations, so using Dairy Base, farms from throughout New Zealand. If you look at milk production in 2020 and you go back to 2000, if you account for nitrogen fertilizer use, supplements, and all the other things that would be contributing to milk production, there's about 2 tons of pasture so either not growing or not eaten now. Most of the models used in forestry are overestimating. Timberlands who are cutting the raw forest, they've been overestimating yields going back probably a decade using empirical models. So they're now wanting to switch to more process-based models. So there's something happening. I think globally, our forests have gone from net sinks to eight forces, I think, in the last 12 months globally. So there's things happening to prime production that I think we need to get our heads around.
These guys are used to so they have to. So given the kind of disparity of responses, where do you see the biggest tension between economic viability and environmental sustainability, and how can they be managed? So we'll start with you, Al.
I've spoken enough. I just said a bit.
Yeah, I mean, I think there's the trade-off between the two has been a focus of the work we've been looking at. And there's an interesting thing related to your productivity and the sustainability, and some discussions we were having with Dairy NZ about this, because productivity in the dairy sector is pretty flat. And we're really concerned about this lack of productivity. But actually, the farmers are being rational economically, and they're making a lot of money at the moment. And so we're sitting here as economists going, oh gosh, we've got a productivity problem in New Zealand. We're not, people not going up, dairy productivity's pastures flat. But actually, if you talk to a farmer, prices have been good, terms of trade are good, their profitability there. And so I guess they're going to be driven by that and what's happening there. And unless the environmental impacts, like we're witnessing with the weather at the moment, are directly impacting them, the tension is the economic sides are going to win, and that's going to create. So they won't. The long-term productivity and the environmental impacts are important, but they're being displaced, I guess, by relative profitability at the moment.
Yeah, I mean, I guess building on that, but if we were going to take a longer term view, I think, there isn't going to be a trade-off, because we're going to need the underlying services of the environment to get the economic benefits. So I know that's not the timescale that farmers operate in, but I think we need to keep that in mind.
Yeah, I think it's really important to credit farmers with their ability to respond. Farmers are smart and they can see the opportunities, and we have incredible things happening on the technological front. And I think, yes, there might be some conflict between environmental sustainability and economic profitability, but necessity is the mother of invention, and farmers are very quick to take up those technologies. So things like finance will become really important in improving their ability and education, training, support for them through those transitions. But that will probably be, as I said earlier, reactive when things happen. That's when we'll start moving on these things. And we're seeing a lot of technological innovation now, especially reducing emissions from livestock. And that could be a real game changer as well.
I think Mike's point there really nicely leads in, because farmers are smart and adaptable and do a lot of hard work to make a system that's financially viable and try and bring in new technology, and sometimes they don't get enough credit for that. I think my problem here comes back to that regulatory problem, and the fact that we've been very lukewarm about going ahead with any legislation which actually puts any dollar cost on what's essentially pollution or greenhouse gases from this industry. It's a very basic economic problem, right? Externalities. I've been literally in this class talking to some students about this very simple economic problem. And so what economists like to do is say there's a cost here which isn't being factored into the cost of production. So you bring it into the cost of production with a tax or some sort of levy, even if it's recycled into the industry to help. But you put something in there, even if it's not enough, even if it's something. Because, to Mike's point, farmers are smart. They'll start seeing that signal and responding to it. So even if you're doing it very slowly, you're giving them a chance to adapt, and you're allowing them to respond in the way they choose to respond. You're not saying you have to do this. You're not being prescriptive. But at least you're giving them a signal that gives them incentive to move towards implementing emissions reduction technologies. Whereas if you've got no signal like we have now, other than the potential of one, if I had the choice to invest as a farmer, well, I've got really no incentive to invest it into something that might be less productive, but would help my emissions. So the sooner we can start giving even a small signal, we can start shifting those incentives and helping farmers adapt themselves, see the problem rather than just hitting it as a brick wall. So I'd say that's the thing, is less the viability now, but into the future that we don't hit a one-off, suddenly you've got to pay $1 million per ton of CO2. Bleed it in so farmers can adapt over time.
Thanks, John. So before I hand it over to the audience to ask you some unmoderated questions, I'm going to ask you one more, and really short, sharp answers. Looking ahead 20 to 30 years, what advice would you give to Kaitiaki landowners planning for long-term resilience?
I don't think I have any good advice to give there. We know we can keep producing dairy, but they're just responding to the signals we give them. So I think try and keep an eye out on that, but really just respond to the signals, and it's our job to help send the right signals.
Yeah, I am a libertarian in this respect as well, because I think they will, make informed decisions without my advice. Who am I to give them advice? They've been doing this for years. They know what's coming. They read the markets, and yes, we can give them better signals. So policy is an important issue here, and the types of policies. So if we're going to put a tax on methane, how are we going to do that? If it's a tradable quota, that's going to be far less disruptive than something like a quota that's not tradable, for example. These are lessons we've learned around the world. So we just have to be smart in the way we create those signals that are going to affect farmers' decisions about the future and their investments.
Well, hopefully in 20 or 30 years, well, by then the farms will have experienced quite a lot of changes in the weather and climate. And so I guess I would say, which they will be doing, hopefully, is learn from the past. Don't make the same mistakes that we did in the past, and try and keep a holistic perspective, not only in the markets.
I guess my view wouldn't be about giving them advice about what they should be doing, but I think what we've got to do is get the infrastructure and the systems around them to help them adapt. And so therefore, one of the things when we were doing Future Use of Land report was this idea about making sure people have got options, and when they need to change, they've got those options to move to. And that means also the finance to support them moving. It means about the advisory services, understanding the different systems that they can go to. So it's about us all around, and the research that we're doing, all interlinked into actually being able to give land users options that when these challenges come, and they're coming, that they are able to adapt, diversify their business and move on successfully.
I'd advise to go out and buy as much Class 1 land as you can afford. It produces the most for the smallest input and has the smallest footprint. So if you're looking to the future, go and buy. It's never going to be cheaper than the so little of it.
Now, I'll look up to the audience for questions. Right, you mentioned 3 scenarios: the orderly, disorderly. You didn't really tell us anything about the likelihood of each of those scenarios. So what I'd like to do is to ask each of the 5 of you, if you had to put your money on the future scenario you think is most likely, so orderly, disorderly, or hothouse, which one would it be? Raise your hands. Orderly? Disorderly?
A mix of orderly, disorderly.
Right. But not
Potentially. Disorderly to hothouse, I would say, the way we're going at the moment.
Yeah, when you present, I'll go. Firstly, thank you to the speakers. Great talks, and quite a panel. Really interesting piece of research and very. I've got a very simple double barrel question for Alec. This decline in productivity, Alec. First of all, how confident are you that we know the key drivers for that decline in productivity at the moment? And moving forward, as scientists, what new data do we need to help build into that?
We don't really understand what's driving it. The working hypothesis at the moment is that in any 1 year, plants are spending more time in conditions which are unfavourable. It's too wet, too dry, too cold, too hot. And the plant then has to recover from those conditions. And put that alongside with some things happening with increasing CO2, something to the nitrogen cycle. Tend to be held, nitrogen seems to be held more tightly. And from the work at the phase, the enriched CO2 experiment, there seems to be declining feed quality, pasture quality, so low utilisation. So there's some things happening with CO2, and then there's some climate things. But I think this idea is more droughts. I think that's a little too simplistic. So that's our working hypothesis. Until we better understand that, then there's a risk you might, follow mitigations that exacerbate don't necessarily. So, yeah.
when you presented the regional differences, I think that was in the total impact on the whole economy. Looked like Waikato is absolutely going down the gurgler.
Yes.
If you, in terms of the impact on individual farmers and sort of regional economy, perhaps presenting it on a proportional basis to current dollar productivity might be more useful. So what were the main drivers of the regional differences?
And so, as we sort of went through with Alec's talk, as we didn't have the opportunity to do a deep dive on each region. So, of course, some were better than others. But you're very right, they're giving some better context as to what's going on would be nice. In particular with the Waikato, I mean, it's quite an obvious answer. In terms of our climate problem or issue in New Zealand, we have an elephant in the room, and that elephant goes moo. So Waikato in particular has 30% New Zealand's dairy herds, I think over 20% of our total production and total effective hectares in dairy. As we've talked about previously, we know the problems in Northland with fodder and trying to feed cattle under these problems with pasture. And we have done research looking at alternate fodder crops, but none of them are as productive as our standard ryegrasses. So the assumption there is if all of these scenarios assume we're decreasing our emissions due to international regulation, due to changing consumer behavior overseas, that's going to hit Waikato. That's going to hit Waikato hard, and that's going to be an economic hit. We know there's other things. We've talked about smart farmers. So there's a level of detail that there are alternatives, but they're all going to be less productive, as we can say. Even if they went into high productive horticulture, very high value, it's still quite intensive greenhouse gas wise at a small scale, and it's not going to replace the size of the industry. So whether we could dig down and say, would that be shared a bit between other regions? You know, you see in some of those Canterbury does quite well, of course, you know, we're the next highest dairy producer, but it's going to be a bit longer before we see those yield effects in the same way that Northland and spreading down to Waikato is going to get over those. So that's kind of why Waikato's hit that. But I'd say looking at ourselves honestly, would say probably there's some adaptation if we dug down. We could look at some other scenarios to mitigate that. But at the end of the day, I think that's kind of what we're looking at and why we're interested in this, right? Is there's a burning hole in our pocket if we don't figure a way to produce our dairy more efficiently, or if we run into one of those kind of big shocks, just run into a cliff that, you know, God, what can we give the people of Waikato to keep them producing something? So I think that's the short. Anyone else, anything they'd like to add on Waikato, please?
Just to remind you as well, that the data that was reflected in that figure is not just for agriculture. So we have an agricultural sector model, which then feeds into a total economy model. So what happens downstream after the farm gate is probably a major contribution there. So if a lot of the product is being processed somewhere else, or the business is being done somewhere else, it's leaking out of that particular district region, and that would be also a factor responsible for that.
And also, I mean, as I said, we didn't have a lot of time and resource to really, you know, track all of those narratives into and convert them into a number. So we can do more into really reflecting everything that's going on. So it's quite broad, I suppose, at this stage. Would that be fair?
Sorry, one last point, just so I have it in mind, is other research we've done sort of independently at this, looking at climate change impacts. It's not just straight yield shocks and change in CO2, it's also a proliferation of different pests and weeds that can be quite climate driven. And you see, of course, that will hit the north of the North Island first and slowly bleed down. So often we'll find the South Island, we're going to be the new capital of the world, I'm glad to say, everyone, so just you wait. But you can see those disparity of regional impacts for things like that as well, the multi-faceted bad things that can come with climate change.
A question principally for you, Anita, but maybe for the rest of the team as well. So just to clarify my understanding, so the orderly, disorderly hothouse are also kind of trying to translate global things. So what we might do here might not be able to influence whether there's an orderly, disorderly, or hothouse scenario coming at us.
Yeah, that's right.
So my kind of question to you really is, one of the things you talked about is your concern that there wouldn't be action taken early enough or leadership. For the orderly one, that's talking about early action in order to put us on pathways. Question: have we passed an early stage? Like, are we already beyond that? And if you think that, and I'm not trying to be, I mean, it's a genuine question. Like, and if you think that we're beyond that, how comfortable are you about presenting an orderly scenario, given that you're concerned about people not taking action early enough and giving, you know, not taking it seriously enough? Is there something that we're doing, and it's more of a general comment to us, of presenting scenarios that have kind of are now no longer possible, but they're the most optimistic ones? So it's kind of a question to you,
yeah,
really, for your team.
That's a great question. I mean, yeah, 20 years ago, it might have been orderly, and we're almost at 2030,
like 2026,
so basically on the disorderly pathway. So yeah, that is a fantastic question, and probably, I mean, that framing of those three futures was developed internationally probably 5 or maybe more years ago. So it's, you know, probably about time that these were updated to reflect the new reality. Thank you.
That's good. It's a really good question. I've got a suggestion to make, and given that you've got several economists up there, the thing that I think is an opportunity for us is if you could describe the size of economic prize as a way to motivate people to make change. If the instrument, I think you mentioned,
we could choose as well. We're going to give you a greenhouse gas price that will give you a tax so you can pay for your mitigations. Probably won't land. If you go, well, we'll regulate you, that's probably not going to land. But if you say there's a fiscal benefit from international food companies from doing this, that might land. So maybe a suggestion you could describe the economic price.
So thank you very much for the very sane question. And, you know, that economists, we deal with human behavior, right? We want to figure out how humans work and address that sort of madness. I think it's a wonderful idea. People respond better to, you know, the carrot than the stick. It's almost like you should have had some sort of research center that was around agricultural economics that worked for many years looking at price premiums and market for low carbon goods and trying to sell this to the New Zealand government and industry, and felt like we were shouting into the dark for 15 years. So really, yes, we've done that research and tried to present to industry. But of course, while dairy prices are high, no one wants to hear it, that in the future, this might be an issue. If you have certain lobbying bodies who will do everything in their power to slow down the progress of legislation and rewind it, no one sees it coming. And as one of the things about human nature we also do, unless people feel it's a real and present threat, they'd rather do nothing at all. And so sadly, while we've been trying to come up with these great win-wins, we get premiums and markets. We're the first moves on this. It's almost too late. Other countries have moved first exactly on our industries. Other countries have better regulation that their farmers are already on the journey. We're behind the ball of trying to get that premium and market, which could have helped pay for farmers to adapt. And you've got stuff to the lactalis saying, well, there's a huge capital injection to New Zealand dairy. Is there any reason any of those farmers will put it towards mitigation technologies? I can't see it. And so we have been trying to push that narrative, but I'm afraid it's just come to the point where now it's more saying, well, there's just going to be a punishment for us. There's going to be a real cost to our industry if we don't do this, because our suppliers, you know, Nestle wants to get net zero scope 1. They know what's going on, and we're going to be forced to react at the last moment. So we might have let the horse already dash, and it's somewhere in the distance of having a positive narrative. So I'm afraid the only one we've got is the cost narrative, which, as you say, is less effective, but maybe that's where we are. Sorry, that's the doom and gloom answer. Anyone got anything more positive? Sadly not.
Last question.
Hi, I'm just trying to look at this in a global perspective. People need to eat. So what I'm taking from this is, you know, we're trying to shrink the grasslands, shrink the herds, put tax on methane from cows, but not on wetlands. You know, so shrinking food production, and maybe some of it's not purposeful, but because of the production of the grass is low. So people need to eat. The more that we have to import, and sometimes that imported food has less regulations on it than what we already have here. So is it an overall benefit if we're shrinking our production and having to import food with all the greenhouse gas, you know, in bringing it to New Zealand, but because people can't afford the premium New Zealand product? It's anyway, just throwing that out there.
Yeah, and I mean, I couldn't cover everything in those narratives, but in the disorderly and the hothouse, there's an increasing tension between what we grow here and to feed ourselves as well as what we export. So it is kind of acknowledged that increasingly we will probably need to shift our focus from exporting to feeding ourselves. But yeah, there is an overall decline, contraction in the productive area because of the nature of the impacts that we're going to see and that we're not prepared. So, and I mean, the issue of importing from other countries, I mean, New Zealand is probably likely to be less worse off than many countries. So less badly affected under climate change than many other countries. So there might not be a lot of other, you know, sources to import from, actually. We might need to think about shifting our focus internally, but I know that's not palatable given we're a trading-based economy. Anyway, it's an interesting question.
Thank you. Join me in thanking the Thank you for attending the first Bioeconomy Series here at Lincoln University. The next one is March 18th, which is Seeing the Unseen, from microscopy to landscape visualization. So hopefully you'll be able to join us at the next event. These are meant to share both the BSI and the Lincoln University activities. We were a little heavy on the Lincoln side of this. They didn't turn up.
Actually, the rest of Alec's team has gone overseas or to Invercargill.
So thank you very much and have a good afternoon.